Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Anita Lasto, and I'm a CNCF ambassador, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies and the stories behind them. They will build things, they will break things, and they will answer all of your questions. So, you can join us every Wednesday or like this, sometimes, especially on other days as well. And this week we have an amazing set of presenters here to talk with us about designing and operating reliable cloud services, a view from the trenches. So very exciting for this special program today. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. So basically, please be respectful of all of your fellow participants as well as presenters. With that done, I'll hand it over to our amazing presenters to introduce themselves. Yeah, who wants to go first?
I'll go first. So my name's Anurag Gupta. I'm the founder and CEO of Shoreline.io and one of the founders of Reliabilityorg. Both correlate to my lifelong interest in building highly reliable systems. Now?
My name is Niall Murphy. I am CEO founder of a teeny tiny startup in the SRE ML space called Stanza Systems. If you know my name, though, it is probably because of the site reliability engineering book, the SRE book, and or possibly the ML Ops book, which are both explorations of what it means to build reliable systems. Stephen.
And I am Stephen Townsend. I am currently a developer advocate for a company called SquidUp. It has unified dashboarding and visibility. I did performance engineering for many, many years, moved into SRE more recently, and I have a podcast called Slight Reliability where I share my learning journey in the reliability space.
Perfect. Amazing group of people here with us today. So today we have a great kind of panel format where I will ask questions and then we're going to get amazing answers. But as always, you can still ask your questions to your audience as we go along. And we'll probably have some time for Q&A in the end as well, but ask them away as we go along as well. So first question to everyone here, what does good or great look like when discussing reliability?
So we only have an hour, right?
Yes.
Yeah. So, like, just off the top of my head, I don't think there's a context-insensitive answer to this. Like, I don't think there is one answer which just fits everything, and I expect most people in the industry wouldn't be surprised to hear that. I will say there's a couple of fundamental questions you have to be addressing to a sufficient level in order for this question to kind of mean anything to you, really. The first one, of course, being how much does the org care about reliability? Like, if it doesn't care at all for whatever reason, like there might be arbitrary reasons, then good or great doesn't really matter. I would say, though, that making sure the basics are kind of done well is always going to be a foundational thing you have to have before figuring out what good or great looks for you even makes sense as well. And that's stuff like, are you measuring what it is that you're doing? Have you decided organizationally how reliable you should be? Like, if you haven't decided that and you're just getting, I suppose, whatever the native platforms will deliver to you, then you have a huge decision to make about precisely what to improve where. And like, are you resourcing it sufficiently? Do you have the right number of people, the right kind of people, the right resources, et cetera, et cetera? There's a lot of folks who are even struggling with the basics before we come to the question of good or great. I will say, though, that if you do define, or if you do have the right measurement infrastructure in place, if you have defined what your levels of reliability should be, and if you are sufficiently resourced to meet those levels, well, that looks pretty great from my point of view.
Great.
So I'd say great to me means that your system is running at a level basically indistinguishable from 100%. So it's a receding horizon. You can always get better. Now here I'm talking about reliability, not availability. Sometimes people confuse the two. They talk about their fleet-wide availability, but that ignores things like, am I getting errors back from the system? Is the performance out of whack? And I often find that people take a fleet-wide availability goal and then they claim they did really well, even if like one region was down for an hour. That has happened to me with some of the services I used to work on at AWS with the services I depended on. And your customers just don't care about your fleet-wide availability. That's an internal goal. What they care about is their particular experience, right? Were they able to check out? Were they able to perform their task? And in the expected time without any drama, and ideally without having to code against a bunch of error cases due to inefficiencies in your software.
Yeah.
I think the ultimate goal of reliability is to support an organization, like to meet its objectives, whatever they might be. So, because reliability, just for the sake of being reliable, I don't think necessarily is enough. You know what I mean? It needs to have a purpose behind it. So I think maybe good reliability is when the org is achieving its business goals, the customers are able to achieve the outcomes they set out to achieve, the ops team enjoy their work, hopefully, or are not totally stressed out by constant incidents and fires burning all the time. The technology is easy to operate, incidents are manageable, and of course the technology is also reliable and available and performs well enough to do what it needs to do. So it's maybe a bit fluffy, but that's my take.
Yeah, it's a good fluffy take. No worries there. Perfect. So next up, we have the next question, which is, tell us a story about a particular or unusual reliability failure that you had seen. Was it a failure of design, implementation, or operations?
I'm going to flow on. I have a story. It's actually from my performance testing days. So I was, and it was the system which was sort of on the side no one was thinking about. It was a system of record. It used to be a mainframe. Over the years, it got upgraded and it got put into a mainframe emulator running on a Windows server. And at one point, we needed to take some of the data that system used and put it in a big cloud repository. So this mainframe system, which was emulated, would call to the cloud to retrieve, customers or something like that. Turned out that no one knew this, but the mainframe emulator, which also its own database was an SQL server, was considered an external component. It would make calls externally to the cloud, and there was a performance issue. It would take like 15 seconds to retrieve a customer. The thing is that those calls were single-threaded, so that when it was making a call to the cloud to retrieve a customer, the entire system would freeze for every single user for 15 seconds. It couldn't even reach its own database to do anything. It was like the worst thing I've ever seen. And I don't know, when I think back on it, I think it was a failure of design. Probably more it's more of a failure of too much technical debt. The system which hasn't been cared for maybe a decade or more, and it just hasn't been thought about. So no one knew about it anymore. So when we're introducing new cloud stuff to the old world and not thinking about and understanding how these things are going to interact.
So I spent about 8 years at AWS. So I saw a lot of failures there. And I'd say the biggest ones were almost a failure of imagination, where the system had an error path to deal with a resource becoming problematic, but it wasn't able to deal with the at-scale case where the failure cascaded. So for example, the week before I joined AWS, there was a huge outage in Dublin due to a lightning strike. And that, because so many different machines went out at exactly the same time, we had this remirroring storm, and where every machine was trying to remirror to some other machine that was trying to remirror to it. And there just wasn't enough capacity, and nothing was going through. And the reason I call it a failure of imagination is because we all can see and code against the everyday things that happen all the time. The question is really thinking about what's the largest scale thing that you're going to go and deal with. Is it a region? Is it an availability zone? Is it 100 hosts? I don't know, but designing for that is really, I think, incredibly important when you're designing reliable systems. Now, you must have seen a bunch.
Again, kind of the margin of this call is too small to contain all of the things. I actually, in a rare example of trumpet blowing, I actually run a podcast called Getting There with Nora Jones, the CEO, founder of Jelly.io, which actually goes into very much detail about incidents and tries to examine them under the framework, or LFI framework, or a socio-technical systems framework, or a safety 2 lens. There's an emerging movement about how folks actually analyze and respond to incidents, which is making quite a lot of inroads into the SRE community in particular, but also in hospitals and like chemical engineering and aviation and a whole bunch of other fields where the standard reaction to incidents can be possibly a little bit more blameful than we might like, and the organization doesn't learn as much as it would otherwise. But in terms of kind of bite-sized stories, like I've loads, I suppose. There's the time that somebody dereferenced a pointer incorrectly and everyone saw the data for customer 0. That was pretty cool. That was not so good because obviously customer 0 did not want to show their data to customer 1 through umpty million. But it was relatively simple from a kind of a contributing factor point of view. Like the code got changed and pushed. The difficult thing was figuring out what the correct privacy and legal response was now that you have this data which shouldn't have been accessed by other folks. Then there's the ones where the technical thing is maybe clear, but you're working internally or externally with folks who might have some trust issues with the framework of authority that you're dealing with, and so you have to kind of establish trust in the middle of an active incident. I had one with a public sector in Ireland where the technical cause was actually relatively clear from day 0 and was something to do with traffic routing, but folks on the call weren't in a position to believe that a large organization could make guarantees about how their systems were performing that the smaller organization was kind of ready to really absorb. So there was primarily a social conversation rather than a technical conversation. And then a little bit like, I suppose, Anurag's story early in the days of S3, the AWS system used a gossip protocol to tell other machines where the data lived. And so if, for example, a system or a data center lost power and all of the machines came back up at one time, they will all go, "Hi, I'm machine X. I have chunks 1 through 70 million. And hi, I'm machine X plus 1. And they would all tell each other and completely flood the network. And they would completely flood the network even worse because there was an assumption that this network, which was actually split between 2 data centers, had exactly the same bandwidth characteristics on every point-to-point link, which of course is not the case if you're going between 2 data centers. So that was fun.
Perfect. A good variety of fun challenges and failures there. Great to hear. But with these experiences in mind, what design recommendations can you share for delivering services with maximum availability?
I'll start. So my first take is you should automate everything, and that you can. Because we've done a decent job over the last 20, 30 years in improving quality. And so I think it's now time to provide that same sort of engineering rigor to reliability as we did for quality. Have things go through pipelines, inject failures, see how they're handled, simulate large-scale events to see if the system can heal. So I feel like the more this is software, the more it scales, the more you can manage it like it's software, as opposed to people and processes intrinsically hard. People change, processes sometimes are followed and sometimes they're not.
I think maybe the biggest challenge right now is just how distributed our systems are and how many components are that need to talk to each other. So we talk about zero trust for security. I think in a way we need to start thinking about reliability in a similar way. So maybe being careful about the vendors that we choose to connect to, and making sure that they're reliable, because at the end of the day, you are only as reliable as the dependencies that you depend on. That's a whole nother way of thinking, I think, and also realizing that there are going to be maybe dozens of components that you're out of your control that you depend on. I was going to say, and building sort of degraded service around that. So if this thing goes down, have a backup plan, or provide degraded service. I think that's one thing. And I guess the other thing is, of course, having really effective observability. And it's easy to say the word observability, but I think being able to pinpoint what's, to understand and see clearly what's happening in a really complex distributed system. It's hard to get right, but when you get it right, I think it makes a big difference to in sort of improving reliability.
Again, there's an absolutely gigantic amount of stuff we could say here. It's even a struggle to keep it to 56 minutes. So I think I'd start off saying, there's a bunch of things you could do at different levels, and some of the levels are maybe relatively tactical or code focused or whatever. One thing that, believe it or not, contributes a lot to reliability problems is, have you checked the return code from your system call or your HTTP request or whatever? What happens if that does not complete and the information that you were hoping to get does not in fact arrive in the buffer, and you just pretend the buffer is there and has something valid in it, and you proceed to crash merrily? There's all kinds of stuff at that level. Then the level up where you're going, okay, boxes and lines, how do they communicate to each other? Is there some kind of resiliency you can think about there on a design level? There's it's not quite a programming language, more kind of modeling language I'm quite fond of, called TLA+. Hillel Wayne and a bunch of other folks do popularizations from it. Of course, it's a Leslie Lamport production from the same folks who gave you, or same person who gave you Paxos and other master leader election kind of primitives. But TLA Plus allows you to kind of model state transactions in a distributed system and say, okay, if this goes to here and we message this thing back with this other information, can we prove that this is correct, or can we fuzz it enough so that we can look at some potentially some cases where potentially reliability might be in threat? And actually, Amazon used TLA Plus in a bunch of stuff and discovered there's some 39 level deep stack of stuff that actually ends up being problematic. A little bit like, I think somebody proved BGP doesn't actually ever converge a couple of years ago or something like that. Anyway, lots of things you can do.
Perfect. How are we feeling? Do we want to take an audience question here in the mix? Oh, perfect. Enthusiasm. That's nice. So we have Lauren George asking, how do small/medium-sized organizations protect themselves from outages from big public cloud providers without breaking the bank? Is it even possible today?
So
No.
It depends is the silly answer I'll initially give. Really depends on what your app is trying to do, really depends on what your dependencies are. There's actually a fascinating piece of work from, I think, Walmart, who are in no sense a small or medium-sized company, but a fascinating piece of work from Walmart, who do kind of multi-cloud spot pricing for instances for stuff, and that's almost the definition of not breaking the bank, I suppose, or breaking other banks. But the basic deal is figure out what you're depending on, figure out if in your application you can use specific cached results or algorithmic fallbacks or hard-coded fallbacks of various kinds. Note all of these may potentially have reliability outcomes that you were not expecting at some future point of time. But if US East 1 disappears, and you are using some subset of stuff, but you can limp along with cached results for a while, like actually that's kind of a win. A lot of people are pushing multi-cloud at the moment, which there's been a lot of discussion about in the industry, and basically the feeling is it doesn't make a whole load of sense to go copy paste for your infrastructure from one provider to another. They work hard at making sure that you can't actually duplicate that kind of thing. A little bit like mobile telco billing models, I suppose. But the real deal is, if you are using a specialized thing that's only available in one provider, make sure it's something you can do without for a couple of hours if you need to, like BigQuery equivalent. But I'll stop talking now.
Yeah, I think there's a lot to unpack in Niall's answer. Let me add on to it a little bit. So I think the question really becomes, to think about reliability the same way that we used to think about security in terms of threats, except now the threats are when you lose availability of your dependencies. And so it's, for how long can you relate? How do you degrade when that happens rather than fail entirely? Like if you're using Lambda and Lambda goes down entirely, you're kind of out of luck. If you are using VMs and a VM goes down, you can probably spin up another VM, particularly if you've got a warm pool already out there. So, it's really a question of tolerating failures, and you can't just duplicate everything, right? Stephen, what's your view?
Yeah, I don't know. I guess my 2 cents is that if you're a small to medium organization and you're thinking about going multi-cloud, have a serious think about the risk versus the cost of what you're trying to implement and the complexity of it. I think it would be a hard case to make to say that's actually worth the effort and the cost. And there's other things you can do, like Niall was saying.
Great. And then we had a few more questions, but I think we're gonna go through some of the pre-decided questions first and get back to a few of those. So Andrew, I saw your question about chaos engineering. We're gonna get to it eventually, as well as Lauren asked about books or articles, and I think that's a great question to maybe wrap up in the end towards if any of our panelists have great resources for everyone to jump into next. And then also I saw the podcast question, and I'm gonna send the links to everyone in the chat. So no worries there. And then to the next question, which is, how do you identify and resolve potential reliability issues before they become your customer's concern?
At AWS, one thing that we all did, even Andy Jassy did, was monitor Twitter, because at least at the time there was people would go onto Twitter and ask, is S3 down or something like that? And your whole goal was to make sure that by the time someone was asking that question, you already knew, you already had the event started, you're already working on it. Maybe you didn't have it identified the root cause, but you're working. And so I think it's a really important question, and it's a really important goal we should all have, because what you're doing as a cloud provider is, you're taking on the responsibility that your customer would otherwise take on themselves, and so they need to trust you. They need to trust you to care about them in a way beyond what they would do on their own. So you just need to be really good at this stuff.
Well, obviously, I think great observability is important. So, and I think that one of the keys there is to focus in the beginning. Let's say you're starting from scratch. Start with making sure the customer can use the service, rather than getting lost in all the myriad of technical metrics and events that you could be tracking and looking at. Because if you can't answer that question, can customers consume the service, then nothing else really matters, in my opinion. I think that SLOs are a good way to potentially do that, but I don't think you have to do SLOs either. But that's contentious, but that's just my particular opinion. And I think the other thing is, coming from a performance testing background, is to be testing reliability during during delivery, especially for a new product, which maybe you can't just go live with immediately and have load on it because there's no customers at first. So testing it is a great way to shake out not everything, because real customers in the real world do unexpected and wonderful things, but you can shake out a lot of issues and understand your solutions and systems and services better. And but beyond, so those are the, I think, ways you can identify issues before customers do. But beyond that, there's all the other things we can do to mitigate the impact. The way that we deploy. Doing deployments like blue-green deployments or canarying or rapid rollback and things that can reduce risk there. Learning from incidents, not just having incidents occur and not gaining something from that, because incidents are fantastic in terms of learning and growing as an organization. And also, I guess the last thing is really prioritizing the services that really matter the most to your organization and your customers, rather than trying to treat everything equally when you might have some administration API that no one uses or it's not important.
Okay, so I'm not saying you should do this, but there is an improvement loop available to you, a little bit like Anurag was saying, where the answer to what to do for monitoring is you do nothing and you wait for the phone to ring, and the phone, hello, sites down, oh, thank you very much. And then you figure out what went wrong, and then you turn that into an observability rule, and you just do that 1 billion times, and eventually everything is covered. Hooray! Except, of course, everything is covered, and so you have 1 billion things to monitor, and it's not necessarily clear which 7 of the 1 billion things actually matters. So that's a question that you can also resolve with this other magic trick, which is we're pretty kind of big back-end people, right? So we think about things in terms of microservices and communicating via SLO, or communicating via RPCs and setting SLOs and so on and so forth. That is back-end language. It's not front-end language. And the interesting thing about the 2023 Catchpoint Blameless SRE report is that it says only 35.8% of respondents said that they had client-side monitoring that fed into their observability that they could make decisions about. And I think that's the huge gap that can help a lot to plug, particularly, or to plug observability problems, particularly if you haven't done what's called a CUJ analysis, or a critical user journey analysis for your site or your service, in some sense, to figure out what the actual people actually want to do and kind of instrument that. So lots to do there.
Great, a good suggestion there. So then getting to the next topic is reliability.org. So why do you see the need for new reliability.org community?
So the reason I started Reliabilityorg, which is a nonprofit, nothing to do with shilling any of our own goods, is that building highly reliable systems is something of a black art, and it's mostly informed by just bitter experience. And that's okay at a hyperscaler because they've got lots of people with lots of bitter experience and they get better, but it's a problem for the rest of us, right? And there's just no good place that you can go to offer your thoughts or to get advice. And so, that's Twitter kind of used to be, but it's less so now. So you kind of want a safe place you can go without a lot of noise and without a lot of vendors that you can do this. So, I asked Niall, I asked, other people like Stephen to join. And, it's early days, but I'm actually enjoying the conversation in there.
That's great. Anyone else want to add their viewpoint?
Yes, I do. I just lost my notes.
Okay.
Where are we? Come on. I actually wasn't aware of any other sort of reliability communities out there that were not based around a particular technology, maybe, or an open source project. So I haven't found one before. So for me, it was like a new thing. But maybe that's just because I wasn't aware of what else is going on. I also think that there's generally been a split between open source communities who are very active, from what I see, and also these sort of commercial communities of people who are built around a technology like AWS or whatever. Right, and so bringing those together, I think, is quite exciting. Getting those different perspectives. yeah, I think cross company collaboration is important as well. Yeah, I think we could talk more about that. But I know someone in New Zealand who's an SRE in quite a large, important organization, and he's the only one. He's one SRE, so he has no internal community whatsoever. So the only chance for him to get ideas and to bounce ideas is to go out to the industry.
On the other hand, he's living in New Zealand. I mean, it could be worse. So I hang around a lot in either role-focused or conference-focused, or sometimes technology-focused. Slacks is what it tends to be these days, rather than mailing lists or whatever. So I like the idea that there would be a kind of a cross-role, cross-company, cross-industry conversation about this that isn't tied to any one particular thing. And that seems to me to be a win.
Great. So how in the future then, now that this great new community has started, how do you see Reliability.org community growing and evolving in the future?
Let me start. Communities are hard. They take nurturing. They take, constantly adding useful or thought-provoking content. And it takes, creating a safe place where you can offer your opinion, even if there's an expert like Niall hanging out there, who might just, say, well, my experience, the answer is 12. And, then what do you do? Niall's not like that. You shouldn't worry. But now, if you want to provide a response.
The answer is 13. Let's just get that right. Yeah, I mean, I don't know. Communities are hard. Things are hard. Maybe it'll be wonderful. Maybe it won't be. I don't know. But I will say that I'm increasingly anxious about the future of the SRE profession in a world which is, I suppose, growing increasingly unreliable. Is that a good word for it? I suppose. And in a sense, like, I have this whole thing. I talked at SRECon a number of times about weaknesses in the intellectual foundation for justifying the value of reliability and so on and so forth, right? So I think those questions are unanswered. I think that part of what's happening right now is this idea that actually things can be worse and it's totally fine, or maybe it's not totally fine, but we'll just do it and move on. And I think that's a terrible user experience and a terrible abandonment of contracts with the user, right? Like, kind of, if nothing else, emotional contracts, even if they're not kind of SLAs. And so I think that kind of stuff needs attention. And generally, one of the ways it makes progress is via cross-community conversations.
I also see the potential in the community for mentoring, mentee relationships, potentially something we could extend upon. And yet, as has already been said, just the idea of having a place where you can put out an idea, bounce an idea with people with a whole wide range of experiences. It's fantastic, and it can't be. I can't undersell how important that is.
Great. And then Stephen, as you were one of the first people to join the Reliability.org community, what made you jump right away in?
Yeah. So I work for a smallish company, around 100 staff. We're building a new product. We haven't hit that inflection point yet where reliability is the key thing. It's more about building the right product at this particular point in time. So I was really excited to be, to have a place where I could go and sort of keep my finger on the pulse and hear what's happening in the reliability world, because I'm not getting the chance to do the work every single day. So that's really a great thing. And I just really like the vendor neutral nature of it, of the community. Yeah, as I said before, most other communities that I've been part of or have heard about have been around a project or a technology. And this is great. I'm excited. I don't know what's going to happen. It's great.
Amazing. So to everyone here, how can people get involved with the Reliability.org community?
You go to reliability.org, the website, you join the Slack, you introduce yourself, and then you start contributing. I mean, it's pretty simple. And the more people we got, the more activity there is, I mean, finally, communities are all about participation.
Great. Good answer, since no one wants to, I guess, add anything. Yeah, perfect. And then now I think we're gonna grab one audience question while we then go next to the other questions here. So Andrew asked before, how trendy is chaos engineering, the practice Netflix pioneered a few years back? And he adds, of course, Kubernetes wasn't as popular as it is today, but your takes on chaos engineering?
So if you'll forgive me for putting on my kind of copy editor hat or like parser hat and going, how trendy is chaos engineering? Like, do you want a scalar answer, like 13? Or are you saying, how important is it that I should know about chaos engineering, or how relevant is it in the industry? I have only my opinion here, like I don't have strong survey data or anything like that. I think one credible group of people who are doing this are Verica.io, if you've come across those. They also run the Void database. Courtney Nash runs the Void database of kind of incident data out of Verica as well. But Verica's main thing is kind of chaos engineering. Chaos engineering is really useful. Like, it's a really fundamental technique. Instead of just waiting for things to arbitrarily break in your production and tidying up after it, you go, okay, I'll break a tiny bit of it all of the time. And if I break the right tiny amount of it in the right place, I'll hopefully learn something that I can make progress on with respect to improving reliability in my production without actually having a complete wipeout event. So it kind of, if you think of outages or whatever as kind of a tree of possibilities flowing from some kind of single node, then chaos engineering helps you to kind of depth first explore a bunch of potential failure modes that you might otherwise only really encounter after they've set something serious off. It has one particular downside, which is, as I understand it, I have no direct evidence for this, but it has one particular downside, which is people go, okay, so you're going to break my production. And they don't like that bit. They go, I would much rather just wait for it to break completely rather than break it a little bit all of the time, because then the moral failure is somehow not directly connected with my actions, which is not true at all, of course. But there is an issue with having the case for it kind of resonate with certain kinds of audiences. Yeah, that's all I can tell you.
Would it be fair to say that if your engineers are already fighting fires constantly and there's a lot of technical debt, that chaos engineering is not probably a good action to take at that time?
I suppose you could make that argument. It depends on whether or not because often chaos engineering is quite complex to set up, because you can't, like, you can set up a simple bot that goes around zapping arbitrary VMs every so often, but if the subset of VMs that it zaps aren't performing different functions, you only ever learn the same thing that you were going to learn anyway. So it's not adding to your additional stock of knowledge. So in order to be really useful for the organization, the chaos engineering has to be doing something nastily and new to you every time. But if you're getting nasty and new things happening to you all the time anyway, like, that's not much additional value. So why don't we just do the thing that we're doing right now, which is nasty and new, until it stops being so new, at which point we can introduce chaos engineering again.
So my quick thought is that chaos engineering can be done chaotically, right? Where you're just doing random things in the chaos monkey kind of case. And I don't personally find that terribly useful. It's kind of fuzzing compared to thinking very carefully about your testing framework or security framework. What I do think is incredibly useful is fault injection, where you really think deliberately about what percentage of things do you treat as a fault, as you call a subsystem, and how well do you deal with those things in terms of retries, in terms of redirects, whatever it is. And that, I think, can be done in a very careful, methodical, way that, you can actually get some use out of, because it's very hard to get useful knowledge out of randomness.
Great. If no additional comments, hopping on to the next topic, which is what are the top causes of major site outages and how can people avoid them?
Yeah, so there's some old data from the second SRE book suggesting that around 70% of outages flow from change of some kind, like config change or binary change or whatever. So stop changing and everything will be fine. Oh, hang on. Actually, I'm very sorry. It turns out you can't stop changing. Okay, so what we have to do instead is to change in a particular disciplined fashion so we don't trigger the unexpected interactions between attribute sets A, B, and C on this thing and attribute sets C, D, and E on this other thing. And that looks like a bunch of kind of relatively well-known best practices, which are still not, universally done today, but CI/CD, testing in production, canaries, fast rollback. I once worked in an organization that wasn't able to roll back and sometimes wasn't able to roll forward, which was also interesting. So organizing your production such that those things can be done is more or less the first step towards tackling that root cause, for want of a better term, for most of those outages.
This is just purely speculation, but I feel like an increasing, I think an increasing number of outages are going to come from the dependencies that we have, because we've got so many dependencies and they're growing all the time. So I feel like there's going to be an increasing source of incidents and outages.
You can feel, Stephen. You're a human being. You're allowed to feel.
I used to work with a guy, and he used to tell me that SRE is DevOps without empathy.
So maybe back into bitter experience, I see.
But I think about, at AWS, we used to have a 2-hour meeting every week where we'd go through the prior week's outages in important services. And so if I think about the collection of, shall we say, greatest hits that were on replay across those weeks, there are always things like database issues, bad deployments, expired certificates, misconfigured network settings. And it's very similar to what Niall was saying. And what's common across that set is that there's widespread severe impact because they have a large blast radius and that they take time to resolve. So how do you deal with that? Well, one thing is that you plan a deployment rollout so that you control the blast radius. You automate the rollback of changes so that you can minimize the time of failure, because it's basically an integral, the severity, the duration, and the breadth of impact, right? And so it's, you can reduce any one of those dimensions and I think make progress. Databases, we pretty much stopped using databases internally because, it's, at least Charlie Bell used to say, like, it's like putting a switchblade in your baby's crib, just don't do that. It's complex software that's easy to use and you should stop using it. Just use DefInmoDB. Opinions may vary. I've written a lot of databases over the years, so I'm something of a fan.
Yeah. Stop using databases would definitely be a message I would not expect to issue from one Anurag Gupta Esquire.
Yeah, I use SQLite at Shoreline for all of the bitter experience I've raised.
SQLite is awesome, actually, and the unit test framework for SQLite is particularly awesome. Yeah. But like type safety is for wusses, I think is the general idea. Yes, sorry, stop. I'll stop now.
No, it's good. It's great. It's good to have some discussion. So how do the best people out there manage their cloud environments?
When I meet them, I'll let you know. I like the best people isn't necessarily the right framing for this, right? Because the environment and the resources also matter a lot. And if, quotes, the best people don't have the right environment or resources to do the work, they'll go to somewhere that does. So like there's a lot of nuance behind that question. But I would say that a lot of the things we actually talked about earlier in this session with respect to understanding your dependencies, figuring out observability, figuring out critical user journeys, making sure you can roll back, all of those best practices are things that, quotes, the best people, end quotes, are either doing or they've got a good excuse for why not. And sometimes it's a question of picking your excuse.
Yeah. I'll add in the idea of designing for reliability. So, it's like, for example, injecting faults in production, which can sound scary, but it's really a question of resilient architectures which can handle it. So, for example, I built Amazon Aurora, and it effectively injects a large-scale event every week because it does a deployment, which breaks, takes 1 out of 6 elements of the quorum out while it does the deployment, and but it handles it without any drama, and that's just because it's designed to deal with that failure, and dealing with that failure means you can also deal with AZ failures or disk failures or network failures and blah blah blah. So I think that sort of basic design methodology, I'm not saying you should all go do 6-way quorums, but I think that kind of designing for the fragility of the environments in which we operate is important.
Great. So now let's grab another question from the audience. So we had Luther asking, my company embeds an SRE team in rotation with different teams in hope to work closely with them to improve reliability and monitoring, occasionally in-house workshops. Any downsides to this approach? Any opinions?
I'll take a crack at it, and then Nell can correct me, because at least there'll be something to approach. So I think the key question in here is about ownership. So who owns the issues, the failures? How do they escalate? I've seen orgs that have put in SRE functions, but everything still flows to engineering to fix because it's just a bump in the wire, and that's useless, right? And having someone look over your shoulder and just tell you, okay, implement, you're not doing processes well enough, you're slouching, you're not typing correctly, that's not helping me make things better. So what does help me is if they're actually there shoulder to shoulder fixing things, which I think Luther's point kind of touches upon the notion of embedding together rather than treating it as a cascade or treating it as a separate retrospective function. Now you know all about this.
Yeah, I mean, there's a huge amount of nuance to this, depending on what the definition of team, rotation, different team, et cetera, et cetera, et cetera. All of those could have a huge impact on what the end result ends up being. I will say I am most familiar with the single individual embedded model rather than the team-to-team embedding. Like team-to-team embedding seems weird. That's a partnership model, not an embedding model. I think the weakness of the embedding the single individual kind of model, where you would have an SRE that would go and sit with a team that has a particular reliability challenge or some kind of knowledge deficit or whatever, for 6 months, say. That's a pattern that's very common in Facebook production engineering, last I was aware. The difficulty with that model is, like, the thing it's good at is responding to particular emergencies or lacks quickly. Yes, these 17 teams have some problem. We will send staff out there and they will fix stuff and so on. Yes, like often it does help, but what tends to happen is if you do a lot of these kinds of rotations, you've no real team identity, at least not one that lasts longer than the period of the rotation. And that turns out, even though you might not think it's that important, it actually turns out to be really important with respect to giving people the idea that they can build a career and have a kind of long-lived contribution to long-running services, etc., all of which are kind of necessary subcomponents of promotion, amongst other things. So that's kind of the upsides and downsides of embedding. The other question, I suppose, that kind of hides behind some of that is, why does the team in question feel they can't do this themselves? Like, are they looking for warm bodies? Because if they're looking for warm bodies, that's generally speaking not a good sign. It's like, I don't care who they are, just get them cranking out the code now. Well, actually, that's maybe not so good. Or are they looking for a specific guided expertise on something, in which case that can sometimes be a bit better. Yeah. Depends, he said, shockingly.
In my last role, we had a different kind of embedding. I guess we were an enablement team, and so we would spend time with one team at a time, helping them uplift because they asked us to, or because there was a particular need. And I guess that worked quite well. But the challenge was that if the team had competing priorities from an organizational perspective, like you must deliver these bunch of features by this deadline, that would just completely blow away anything we were trying to do, because they just couldn't listen. They were too busy worrying about all this other stuff they had to do. So if the priority isn't there, then embedding is and that sort of enablement is pretty hard.
I found it worked really well at AWS to inject a highly skilled person right when the service was launching, because typically the service team members didn't really have any understanding of how to operate in production or deal with all of the various processes, and so having someone sort of help them train those muscles helped.
Great. So now we can enter the audience Q&A. Not that we haven't taken audience Q&A already here, but if you have any questions in mind, now is the perfect time to ask them, because we have a bit less than 10 minutes left. So type them away. And while we wait for people to type their questions, if they are now frankly typing away, let's ask the last question from my side. So tell us about the best. Oh, we have immediately a question. So let's jump into that and leave my question a bit later. So have you found that those with certs, such as Azure, AWS, and so forth, are better at thinking through designing and operating reliable services?
What's meant by certs here? Is it?
I think it's cloud certification programs.
Oh, certifications.
Yep.
What's your view?
So I have a definite view on this, which may not be shared by other people. He wanted to warn everyone. Yeah, like you say, Lauren, I have no certs. I never met, in 11 years in Google, for example, I never met a single person that had a vendor-related cert. I think that's true. And in general, I'm not saying you should be suspicious of them. Like, there's the certificate having people are people who said, this thing is important and I should work towards getting knowledge about this thing, which is a positive signal, like hugely positive signal. But often, like, that's an abstract way of representing the situation with respect to certs. The concrete way of representing the situation with respect to certs is often like there's a very fixed set of knowledge you have to have, and that fixed set of knowledge might not map onto your problem domain, and it changes quite quickly as well. Like I know back in the very old days, like the networking certifications that Cisco used to do, CCNA and all that kind of stuff, you would spend, 36% of your life learning about the difference between type 2 and type 3 LSAs in OSPF. And how relevant is that to you, really? Probably not that relevant. I suppose it helps to distinguish you from the larger mass of people formally, in some sense, who have no experience with these ideas, but it isn't in any way a guarantee that they will successfully wrestle with your particular problems.
Yeah, so I kind of agree with you. I feel like you can kind of have three tiers of people. There's the tier who actually kind of don't know what they're doing. And then there's a tier where, they've shown through some sort of certification that they kind of know what they're doing. And then you've got this tier that you really want, where they really know what they're doing because they're working at it and they're way too busy to get certifications. And so the problem is, how do you distinguish between the top tier and the bottom tier? And, assuming you can do that, I don't think certs matter. If you can't do it, it matters a lot, right? I mean, suddenly everyone's been a, AI engineer for the past 30 years, and I kind of doubt it, but, that's how they describe themselves.
Great. Anything to add, Stephen? Anything? Okay. And then we have one question from the audience, but I also want to address Shubhaman. You're asking about the profile as a community member on LinkedIn. I think there's going to be a good resources online about how to change your profile around. I think we don't have the time maybe to handle that question here, but I do want to get back to Lauren's earlier question about any great books or articles that can help guide monitoring and observability of automated services so that alerts are meaningful and actionable for teams.
Yes, so there is yet another book called the Service Level Objectives book, primarily written by Alex Hidalgo, the SLO book. It has a chapter in it about SLO monitoring, which happens to be written by somebody called Niall Murphy, who I've never met. And this Niall Murphy wrote about how to do pretty concrete steps with respect to SLO-based monitoring and observability. I've been told it's a really good introduction. That might be a place to start. There are a lot of other monitoring things, like resources out there. Honeycomb has an observability book, which I think is very good, actually. Yes, excellent. Stephen's holding it up now, and written by many of my favorite people. And there's also some sections in the SRE books about monitoring as well, and something from James Turnbull, I think a couple of years ago, called The Art of Monitoring, which I also think is freely available online. Yeah, loads of places.
There's an annual conference called OliFest. You can just still go to olifest.org, Oli with the ones, and I think you can still watch them all for free. And there's tons of really good content there if you want to watch those.
Monitorama, yeah. The other thing I'd say is that pretty much everyone who's a luminary in the SRE community is sitting on Twitter, and you could just reach out to them with your questions, and they're pretty nice, So I follow a lot of people there, and they're pretty generous with their time. So, can be better than reading some dusty book.
Great. No, anything to add there, Niall, still, or?
Yeah, I was going to say that also ChatGPT might help you to write your code, and they might be more available than the time of some of the people on Twitter. But yes, folks are generally available.
Yeah, perfect. But I think that's all that we have time for today. But great to see so many amazing questions and answers from everyone here. And thank you always, everyone, for joining the latest episode of Cloud Native Live. It was great to have a session about reliability here today. And also love the interaction and the questions from the audience. And you can always tune in the coming weeks. We have more great sessions coming up. And thanks for joining us today, and see you all in the coming weeks.